Hello guys, welcome to today's daily Leetcode challenge. Let's solve question 1235, maximum profit in job scheduling. So going off by what we had yesterday, this is going to be another dynamic programming problem, purely because Leetcode tends to bunch up problems of specific types into these clusters. So there we go. That's a hard level problem. Let's get into the description. So we have n jobs. There are where every job is scheduled to be done from start to end time, obtaining a profit of profit. All right, so pretty easy and intuitive. We have jobs that are represented by these three arrays. Start and time represent when the job has to be started and when it ends, and profit is the amount of money you make. You're given three arrays. Return the maximum profit you can take such that there are no two jobs in the subset with overlapping time ranges. If you choose a job that ends with time x, you're able to start another job right away that starts with time x. Okay, so then we have some examples, and it's clear here that the job with profit 50 overlaps with the job of profit 10, job of profit 40 overlaps with the job of profit 70, so we're not able to, and then also these two guys overlap. So we're not able to do all of them, but we choose the two that don't overlap and provide us with the maximum profit. Okay, I'm gonna start coding right away. I want to, and I'm actually just running a bit late on something, but what I want to do here is, first of all, bunch up these two seemingly distinct arrays into one that I can control together. That's done with zip. If you were to print jobs right now, you would see a array of tuples with end, start, and time profit sorted by the first value of the tuple, which is the end time. Why I want to do this, I'll get into it later a bit, but let's have another L, and this is just going to be start time, that's just my length. I want this to live here. Let's say I want a DP array that initially is just all zeros, and it is of length profit plus, or it represents the decision that I'm going to be making of whether do I take a job or do I not take a job. And then for I, and then let's destruct this. I have an end, start, and profit. And enumerate. I'm going to enumerate my jobs here. The decision again here that I'm going to be making is, do I take the current job or do I not take the current job? And then, okay. What bisect right does is finds it's essentially a binary search over the value that I'm going to be putting in here, which is jobs. I'm going to look for a specific start. I'll get into why in a bit. I'm going to, and this is optional. I'm going to specify that I have a high of I, meaning that please in the jobs array don't consider anything above high. And I also have to specify a key because the array that I'm searching over isn't a simple array, it's an array of tuples. I'm going to have a lambda here that only looks at end times. So what's actually going on here? Well, this index is going to tell me for the job that I'm currently looking at, what is the closest job that precedes the current job that wouldn't interfere with the job that I'm doing right now. Why is this important? Well, this is the ultimate question that I'm asking, right? I'm asking this question all the time. The job that I'm currently looking at, that I'm currently considering, do I end up taking it or do I not take it at all? Well, if I take it, then I have to consider only previous jobs that don't interfere. And this index points me to to the last job in the array jobs that doesn't interfere with my current job. So it's very important. Next, I'm going to use this DP array, which stores the maximum profit that I would have collected given that I end at a specific job or that I take a specific job. DP of I plus 1 is going to be equal of max of DP I and DP of the job that I want plus prof return DPL. Okay, quickly about this. Well, I'm defining DP as an array that stores the maximum profit that I can take given that I'm at a specific job. Or no, sorry, given that I'm at a specific end time. So for end time everything up to time unit 1, I'm going to be here considering what is the maximum. Do I take the job? That ends right now, or do I not take the job at all? And that's how, these dynamic programming problems are defined. They're defined by a recursive relationship between some decision. That's exactly what's happening here. So we're beating a good amount of percent, about 90. I'm going to end it here because I have to unfortunately run, but hopefully this was intuitive and easy to understand. This is a hard level problem purely because of the not very intuitive way of defining the recursive relationship between either taking a job or not taking a job. All right, well, thanks for watching. Please like and subscribe, and I will see you tomorrow.